Hi everyone, can anyone hear me? I'm not sure if I should start yet, but this is going to be recorded anyway, so I guess I'll start. Let me share my screen. Okay, so starting off, hi, I'm Mate. I'm from Herodotus, and we are basically doing storage proofs. We are doing uh, cross-chain storage proofs as well as proving historical data within one chain. And as this is Starknet Hackathon, and we very much like Starknet, let's focus on Starknet this time. And as far as I know, we should on the Starknet do stuff on Girly, not Sepolia, so just a warning. And we do offer Girly to the Starknet Girly connection. So let's get started. You can always like find any information and data you want by following links from our website and on our GitHub. And what we will be doing today is the tutorial charity token. Like, don't get too hung up on it. It's just a tutorial to just showcase the whole flow of how you would prove something from L1 on an L2 with using the proof in a contract on the L2, in this case, Starknet. So for anyone interested in like following this in code, like this will be all pasted later on, but still, if you go on Herodotus dev GitHub, you can see the tutorial charity token. I'm not sure if I can paste a link here on Zoom, but it's available on our GitHub. I will just literally now make it public so that everyone can see it. Yep. Jesus, so many checks. Okay. So now it is public, and when you come in on GitHub, you will be able to see it. As you can see, it was worked on recently, and we will improve this for the people who will be watching this in the future and having a look at this in the future. But starting off now, we have a few things that we want to do, and I think before code, let's have a quick look at some diagram of like what scenario we are handling today. So can I add this? Okay. Uh, we will be looking at something like this. So imagine we have a charity contract on a 3 year, and we can just pay money to this charity. It's just, I don't know. Oh, it is a contract where you pay in money and it goes for charity. Let's assume that. So we have a guy who just donates the money, and then basically what we want to do is when we are launching some token on L2, we want to take into consideration how much people donated to this charity. I don't know, because we want to. So we create a contract on L2, and what we want to be able to do is release some token, some airdrop for a designated person who first contributed to the charity. And how do we do that? We basically have a like we basically want to have a proof. We want to request a proof from our Herodotus that will be available on Starknet Girly and that we can consume in our contract on L2. Yeah, I think going into code will make it clear. So starting off, we create some project with Solidity. So all the instructions, I will make it a bit more detailed for people doing it later on. But for now, you just have to have Foundry installed. You get your private key. I mean, you can get it for MetaMask or whatever. You just get you have to have the API key. You have to have the private key. Then you need the RPC URL from any provider. We are interested now in Ethereum Girly and the Starknet Girly. So for this part, you need Ethereum Girly RPC URL. Then you need an Etherscan API key, and now let's get to like having a go at coding the contract. So I have this repo initialized here. So essentially, you just come in and do like Foundry init. And this is our simple contract. We have some donation info struct, which is like Starknet address and amount. And then we have a donation event that we will be talking about later on. And the most interesting thing for us, because we will be proving an actual storage slot from this, is the benefactors mapping. So it's a very simple mapping from an address to donation info. In this case, the donation info is our like Starknet address and amount. I will get to it later on. But what we can do in here is we can donate. By donating, you just send any amount of money, and it's being just added to the benefactors mapping. So we keep track of how much money you donated from your address. And then we also keep track of a Starknet address that you sent to us. I'll get to it in the future as well. There's also just some simple function for withdrawal for the owner or something like this. But it's just playing around. I'm just showing how you do stuff. So what we are interested in is actually this benefactor mapping, and we will be focusing on this. So this is the Solidity side. And then from the other side, staying on contract, we have the Cairo side. So yeah, in Cairo, we have another contract. This contract is our charity token, or however it's called. And in here, we have a ERC20 from Open Zeppelin. And then what we want to do is we want to have an interaction with Herodotus. So how do we do that? First, on the backend side, so we have this off-chain backend thing. So let's just close the contract for a second and focus on the backend side. So on the backend side, you need to like somehow catch the intent of proving something. So what I decided to do in this repo is basically in Solidity in the charity contract, you have the event of donation. And basically, whenever a donation is made, you emit an event. So let's say we want to write a backend for this. So how would that work? You come into Herodotus. You can have a look at the docs. You can like learn how to make the API key. But yeah, later on, like after getting this, you get your API key and you're ready to make the request. If you want to have a look at how to make the request, I think like the best resource would be like if you want to learn about design and finding all this stuff yourself, you can see our docs. But there is also like a hands-on experience, so you can have a look at our GitHub and find the YAB integration breakdown. And then you can follow it and you can see some nice result finding, but we will do that in this workshop as well. Okay, coming back. Another place where you can find stuff for Herodotus is our API docs. So you want to go in the Swagger UI of Herodotus, and then you can schedule the events, you can schedule the proofs, and you can get everything you need. But we will be doing that in code, as we want to like automate that and code it properly, not just do it once from Swagger UI. So in the off-chain main backend, we have the scheduled runs. Pardon my errors, but I would have to open it in another window because my demo setup somehow is broken. But okay, so we have two crons. The first cron will be the scrapping the donations. So we have our contract that is deployed on chain, the charity contract that we did before. And on the charity contract, we have those events. So basically about those events, you just donate stuff and then it emits an event. So I can like donate some stuff in here. And after I do the transaction, there is an event. So right now we have some 3 events from like the last 2 hours. So we will be just working on those, but feel free to play around. And okay, first, we scrape the event. And once we have an event, we can proceed with scheduling a Herodotus API call. So we need to get a few things. So the most important part in here is finding the correct storage slot that we want to prove. We know how the contract looks like. We know how the storage slot layout is. So there will be a point about this in the README, but basically you can use forage and inspect a contract. Let's just quickly do it so you can see what I mean. Okay. When you go into the Solidity contracts, you just place this command, and this will inspect the charity contract for us. You can see that there is this benefactor mapping here, and the storage slot is 0. We can also see how it looks like, and we know how the interface looks like. And based on that, we will be able to get the storage slot we need. Okay, so in here we are just scheduling currents, and we are getting like the everything that is needed at this point. And then let's go into get slots. The get slots needs we need to like get the actual slot that is going to be sent to the API, and then that is going to be used to prove as a storage proof. And here we have a destination address slot and amount slot. And what does it mean? When you go into the Solidity contract, you can see that there is the Starknet address, which is the destination address that we want to like claim everything after. And there is the amount. And the mapping itself is from the address to this struct. So this struct saves 2 storage slots. Like each element in the mapping corresponds to 2 storage slots. The first storage slot is the address, and the second storage slot is the amount. So we want to get both to be able to work with that. So the storage slot, we first get the storage slot for the address. So we paste the address, we get the storage slot for the Starknet address, but we have to like first get the key of the mapping. In this case, the key of the mapping is the address, our L1 address, so the address on girl. And here we paste in donations mapping slot, and this we got from this function. So we can see that the mapping slot is 0. So in here, this one is 0. Once we get this slot, the second slot is easier to calculate because we just add 1. This is just a subsequent slot, and we just get it. We get both slots, and then we can proceed with making a Herodotus API call. It looks like this. This is the JSON body that you need. So you provide a destination ID, in this case, girly. The fee is 0 because girly is free on our backend, so you can make as many queries as you want. And then you provide the origin chain, which is 5 girly, and you provide that you want to prove a slot in a given block. In here, we provide the block of the event, so the block in which the event happened. So for example, if we were proving this event, if we wanted to prove that basically this donation happened, then we would take this block number, we would use it here, and then we pass those storage slots as follows. So the storage slots are actually connected to the address of the benefactor. So basically for each benefactor, you would have to prove this at least once, because you can obviously prove it in different times. So this block number doesn't have to be the block number in which the event happened. It can be a block number in the future. It can be anything you want. So in a year, you can reevaluate all the proofs and or just prove it on demand. You can do anything you want in here, but we just made it this way so it's visible and quick. Okay, so you schedule the API call. You send the API call to Herodotus. This is the interface, and the only thing you want is in config, you paste in your API key, which you get from the main Herodotus website, and it's free. So don't worry about anything here. After proving it with Herodotus, you will get an internal ID, so Herodotus query ID, and by this ID you can identify the query and you can check its status. So the last step in our whole off-chain backend thingy is just checking the status. So checking if the query is done. So this is how it looks. A second, this is hiding stuff from me. Okay. We found all of our events. We construct a few things about them. We will get to that. And then for all of the events, we sent a query. We got a query ID from Herodotus, and we got all the queries back. So currently, if you do it on this contract, most of those queries will be done in 2 to 3 minutes. But if you generate more events, then the new events might take around 15 minutes to be done. So just don't rush it. And yeah, generating storage proofs is not fast. It's not like you send a request, 10 seconds and it's back. Sadly, it's not that fast yet. So be patient. And okay, leaving the off-chain part behind, there is the last part that we need on the Cairo side. So once we've got the response from Herodotus that everything is proven and ready for us, we just need to access it on chain. So for this purpose, you can go into the docs and you want to find the fax registry address. So you go into contract addresses, you find the chain you're interested in. We are interested in the destination chain. In our case, it's Starknet Girly, and we grab the fax registry address. Once we have the fax registry address, you need to write the Cairo contract, or you can just access data from the fax registry itself. So just to show this to you, okay, this is a bit further in the back. Okay, on the start screen. Okay, I didn't copy it. Nice, very nice. Sorry. Okay. In here, you can get into read-write contracts. You're interested in read, and you're interested in reading the slot value. So in here, you provide account, block, and slot. So you have all of these things constructed in here. This one is what? Account is the benefactor. The block is here. And the slot is here. Okay, same problem. Okay, so actually I recommend doing all of that in code because both Starscan and Voyager are not really good at displaying like custom structs and enums returned from Cairo contracts. So you won't be really able to just have a look at it quickly from the Explorer. So if you want to check it in code, there are two ways. So the first way is the way that we have for you on the YAB integration. So in here, if you want to have a look how we do that, is like when you access the slots, you just have to get the fax registry contract address that we got in before from the link. You have to have its API and basically read it. And when you read it, you will be able to see the value that you've proven. But in our tutorial that we're doing today, we will be actually using this on-chain directly and not just reading it from off-chain. So to use it on-chain directly, we need an interface of the fax registry contract that is an internal Herodotus contract. So again, you have to go on our GitHub and you have to find the EVM fax registry. It's all written in our docs, but it will be available in one place in this README after this presentation. So you get the fax registry contract. We are interested in only one function, which is the get slope value. Once we get it in here, we can use it in our contract. Again, this is just a Open Zeppelin ERC20 contract. It's just pumped up a little. So when we construct it, I put everything in the constructor like here, so that I don't have to go forth and back with the console. So we put in our fax registry contract in here, and now once we like someone and once we claim like once we prove everything with Herodotus like we wanted, so once we run our backend that is having two crons, one cron is listening to events, second cron is proving all those events, so that everything is just automated. So if you make any request, if you make a donation, it will be up here in here while the backend is running, and it will prove it automatically with Herodotus, and everything will be available on chain. But yes, once it is available on chain, someone can claim the money from this charity token that is giving you airdrop based on an L1 contract. This is an L2 contract on Cairo on Starknet early. So yeah, just having a quick look at it. This is how you use the Herodotus fax registry. In this case, we are getting two slots. So we are getting the claimer slot. So this is the thing, if you remember when we were in Solidity, we saved the Starknet address. And this was because we don't want just anyone to be able to claim this money on Starknet. That's why we saved it on L1, proven it, and made it available on fax registry, on Herodotus fax registry on L2. And now we can basically compare the claimer that was like published on L1, that was attached to a donation on L1. And only if the caller is the claimer, is the person that sent the donation in the first place, only then we allow to claim the tokens. And the second thing is we check the donation amount. So this is why we made two stars. We proved two storage slots and we made two fields in here. So we had the Starknet address that we talked about just now, and we also have the amount. So in this place, we check the amount. So we've proven it with Herodotus. It's available in the fax registry on L2, and you get the amount. Based on the amount, we calculate some airdrop money. So we just like double it or something. Yes, double it. But yeah, anyways, we get some nice money amount. We check if the tokens were already claimed. If not, we proceed with minting. So we mint the token for the user. We're happy, and we just mark the accounts that it minted this many tokens. Yeah. But basically, this is the whole flow. We start off on Solidity. We have some mapping that we're interested in. This can be a contract that you write, but this can also be an external contract. So if you want to prove something, I don't know, from Uniswap or like anything else. So you find a contract on no one, you find it, so it's source code. You calculate the storage slots. So this is this step. You calculate the storage slots. Once you have the storage slots, you prove them with Herodotus. After you get the status from Herodotus that it's done, you're ready to go. So after it's done, you can either do it as in the YAB integration tutorial. So you can just read them off-chain and do something with the proof off-chain. Or you can use the proof on-chain directly, like we did here in the Cairo contract. So yes, that's basically it. Obviously, for this hackathon, if you have any questions, just ask. We can help you with finding storage slots, because we know that can be tricky. We have a few useful tools that we can share with you. I will post more resources on Discord, on our Herodotus Bounty track. And I'm here available if you have any questions, or if you want to discuss your idea, if you want to like get any help with proving stuff, just reach out. And yes, I guess that's it. If you have any questions, I guess that now is the time, but I don't really see much activity here. Yeah, stop sharing now. Um, I guess. Oh, sorry. I didn't see this. I didn't get any notifications. 1 second. Okay, cool. Have a good one. See you guys and see you on Discord. Bye.
Hello.